idea. This is a simple relationship. The idea is just I want to do a fast division. Fast division in the sense so that while doing CT you should not have any hamper. And I suggest today and now onwards you just prepare for this chapter. At least 4 to 5 sessions I'll go on this chapter. Definitely you have a need questions, minimum 3 questions I believe. 2 at any cost from this particular chapter. That is electric charge and a field. So I suggest you prepare. Coulomb's law, as I said, mathematically Q1 Q2 by R square and K times Q1 Q2 by R square after removing proportionality constant. And this indicates unlike charges. And this formula, like charges means here you have plus Q or minus Q minus Q. The product gives plus into plus, plus minus into minus also plus. These formulas F12 and F21 are written for like charges, and this Q1, Q2 unlike charges, one is positive, the other is negative, or this is negative, this is positive. You can write a formula attractive force. There are 2 types of forces, attractive force and repulsive forces. 2 types of charges, positive charge and negative charge. The formulas are written for your convenience. The basic properties of charge very systematically. There are 3: additivity, conservation, and quantization. So first, additivity is mathematically written. You can cross-check. Property. Second property is very interesting. Charge is conserved. The total charge of isolated system is always conserved. So when you have a charge, an atom, the atom exhibits neutral state. You have a positive charge nucleus, you have a negative charge electrons, so which revolve around the nucleus. The third property, the simple property but a meaningful formula, quantization of charge. Charge comes in quantized state. So it is Ne. N is a fundamental charge and its value is fixed. Whether you take a hydrogen atom, helium atom, you take copper atom, you take whichever atom you take like uranium, all are made up of electrons or they are protons. Of course, the proton or electron, they are fundamental in nature and their value is going to be charge property is going to 1.60219. Of course, decimal places increase. You can say 1.6, 10 raised to minus 19. So after moving from here, I had a small, yes, this I hope in NCERT we have not taken care. We'll address it. Force between 2 charges in vacuum, it is vacuum means air or vacuum, it is not 1/4 pi epsilon. K stands for air or vacuum. If not, you can call. So Q1/Q2 R square. Next, very meaningful formula. Think instead of air or vacuum, I put these charges inside the glass or inside the water or some other medium. So it is called force between the same 2 charges. Q1, Q2 are the same 2 charges. In case of a medium, the distance I retain the same R. The formula becomes 1/4 pi. In the above relation becomes, it is 1/4 pi epsilon 0 epsilon m. Epsilon m stands for, yes, it is relative permeability. What is this relative permeability? It is a ratio of permeability to permeability of air. Let me show you very systematically. So for air, epsilon R, so there is a small difference. Here this is permeability of a medium. The product is going to be simple relation. F air equal to F naught. Now, see this statement. The force between 2 charges is always maximum in case of air. This F naught is always maximum because the denominator, this is only 4 pi epsilon 0. Here it is epsilon m. And dielectric constant K may be defined as the ratio of force in vacuum and force in a given medium between 2 charges separated by same distance. K is defined as the ratio of F0/Fm. F0/Fm, that is a statement defined as the ratio of force in vacuum F0/Fm. Let me write it mathematically. F0/Fm equal to sigma R. This sigma R and of course this sigma m, epsilon m are one and the same. So interdependent Fm comes here, that is force in a medium equal to force in air divided by dielectric constant. So this symbol and the first symbol are one and the same. People write in different textbooks K or epsilon R. It is called relative dielectric constant. Let me go for a small example you will appreciate. A polythene piece rubbed with wool is found to have a negative charge. Polythene piece, you are rubbing with a wool piece is rubbed polythene piece rubbed with wool is found to have a negative charge, means polythene acquires negative charge, wool becomes positive charge, means wool loses charges. So polythene piece is going to acquire a charge of 3 into 10 to the minus 7. Estimate the number of electrons transferred from wool to polythene. That's why the question is very simple. You need to associate. Estimate the number of electrons transferred from wool to polythene. How much charge is transferred? See, the question is total charge is given. What is the total charge on the polythene? It is 3 into 10 to the minus 7. Estimate the number of electrons transferred from wool to polythene. You have to calculate the N value. The property charging by induction, of course, on this base, I had a small numerical. Charging, there are three types of charging a body. There are three methods of charging a body. First one is by friction, by induction, and by contact. Of course, charging by induction, let me write. Charging a neutral body with the help of a charged body without making actual contact between the two bodies is called charging by induction. Means bodies are not in contact. When you bring a charged body close in contact with uncharged body, induction takes place. The charge developed on the neutral body is called induced charge, and the charge on the charging body is called induced charge. The induced charge is less than or equal to induction charge, and their nature is opposite. This is a meaningful statement. The induced charge is less than or equal to induction charge, and their nature is opposite. Means you bring a positive charge body, think you have a neutral body. You have a neutral body, you want to make it a charged body. So when you bring a positive charge body, there will be an induction, and the uncharged body will acquire negative charges, and the uncharged body will becomes yes. The induced charge is equal to the inducting charge only when the inducing charge is very close to the surface or completely enclosed by the surface on which induced charge develops. We have discussed at length. The formula is this. If Q be the inducing charge, the charged body, then the induced charge on a body having dielectric constant K. Think the body is some other body whose dielectric constant is K. The induced charge is given by Q dash. The induced charge is given by Q dash equal to minus Q inside bracket 1 minus 1 upon K. So look at this mathematical equation. This is purely in terms of a Q. When a K is a pure number, it is 1 minus 1 upon K minus Q. Why? If you bring a positive charge body, the induced charge body is negative. If you bring a negative charge body, it becomes a positive charge. So in case of conductor, think conductor has a dielectric constant. Do remember its conductance dielectric constant value is infinity. So K equal to infinity. Hence, induced charge Q dash equal to minus Q for conductors, that is metals. Two conductors identical in shape and size. You have conductors identical in shape and size, but one silver and the other of aluminium. One is a silver, the other is aluminium. Both are conductors. Which is less conducting? It means compared to silver, aluminium is less conducting. Are both placed in an identical electric field, means both are subject to an external electric field. In which metal will more charge be induced? In which metal more charge will be induced? Let me address it mathematically. There are four choices. The induced charge will be equal. The induced charge will not be equal, may be equal or may not be equal. None of the above. The answer is here for you, and the answer is going to be the first one. We will address it. In case of induction, maximum induced charge is given by Q dash equal to minus Q1 minus 1 upon K. In case of a conductor, both are conductors, two conductors we said. When you have a conductors, whether it's a silver or aluminum, K value is infinity. Hence, induced charge is going to be 1 minus 1 upon infinity. Hence, Q dash equal to minus Q. So the induced charge will be equal. That is, in both the metals, induced charge will be equal. However, in case of conduction, the current in silver will be more than in aluminum, as it is more conducting than aluminum. Here, if 10 raised to 9 electrons move out of a body to another, if 10 raised to 9 electrons move out of a body to another body every second, how much time is required to get a total charge of 1 coulomb on the other body? I repeat, if 10 raised to 9 electrons move out of a body to another body every second, how much time is required to get a total charge of 1 coulomb on the other body? So I repeat, in 1 second 10 raised to 9 electrons move out of the body. Therefore, the charge given out in 1 second is 1.6 minus 19 into plus 9. So it simplifies to 1.6 minus 10 coulomb. This is a charge in 1 second. So if this much is a charge in 1 second, to accumulate 1 coulomb of a charge, how much time required? Cross multiplication. So the time required to accumulate a charge of 1 coulomb can be estimated 1 coulomb upon 1.6, you will get 6.25 plus 9. And finally, the answer is going to be 198 years. I converted second in terms of years. So do remember each year equal to 3.15 10 raised to 7 seconds. So 1 second equal to 1 divided by 3.15 10 raised to plus 7 becomes, of course, you have plus 7, it becomes minus 7, then you have in terms of years. Everything is simplified. Thus, to collect a charge of 1 coulomb from body which 10 raised to 9 electrons are moved every second, we will need approximately 200 years. Therefore, 1 coulomb is very high for many practical purposes.